Hi, my name is Madison, and I'll be talking about continental drift today and how that became a theory. So, continental drift is the theory of how the 7 continents and 5 oceans we have today came to be from a giant supercontinent called Pangaea. So, before this theory was developed, there are a lot of different theories going on. Some of the main ones included that the Earth started out as a giant ball of magma. And during its cooling process, it began to shrink, and that caused all of the mountains to form and the oceans to form. And then there are also theories about how those mountains and oceans came to form because of continental collisions. So it's just kind of like the continental drift, just with the continents colliding together to form formations we have now. And then, so Frank B. Taylor thought a lot about the continental collisions that were occurring back then. And then other scientists like Antonia Snyder Pellegrini believed that the identical fossils, people noticed that there are a lot of fossils that were similar between different continents, which just made no sense to them because the climates were so different and they were just so far apart. They had no clue how the animals and plants would have moved all the way to that different continent across vast oceans. So Frank B. Taylor said, Antonia Snyder Pellegrini said that there were land bridges back then that stretched over the oceans, and that those were used by the animals and the plants to spread over the oceans and the seas to get to the other continents. So this whole shrinking of the magma drying and shrinking and the land bridges were big beliefs for a really long time. People stuck to them until continental drift was pretty much proven to be the only one. They just became laughable in the scientific community eventually. And then others like Alexander von Humboldt saw in the early 1800s when maps were beginning to get developed that the countries or the continents kind of fit together like a puzzle piece. So they started to think maybe those continents used to be connected, and that's kind of where Alfred Wegener came in. So Alfred Wegener was a geophysicist and meteorologist in 1912, and using Humboldt's theory, he saw that the shorelines and the shorelines of continents like Africa and South America seemed to fit together like a jigsaw puzzle, and he began to compile data from the trends with the fossils and the rocks in those continents. That helped him develop the theory that they were all at one point connected, and he coined it a Eurocontinent, which later became known as Pangaea. So most of his data then, he just didn't have enough solid facts because he only really had what could have been a coincidence of the fossils and the rocks and everything being the same in those areas where they seemed to connect. And then he ended up dying in 1930, and he never got to see how his theory became to be accepted by most people some 30 years later. So how did Wegener come to his theory? So, like I said before, he dug a little deeper than the other paleontologists, and he saw that the fossils seemed to extend through the countries. So if you look at this here, the Kinognathus, I'm not sure how to pronounce that, was found between South America and Africa, and then also the biggest one was the Mesosaurus, because these had very different climates and they're so far apart. And then he just found just big trends that would not make sense for how they're spread now when the continents are the way they are. And then he also looked at mountain ranges such as the Appalachian Mountains in North America, right here, and in the Caledonian Mountains in Scotland, I think it might be. Scotland's Caledonian Mountains, and then he also looked at the ones in the Karoo Strata in Africa and the Santa Catarina rocks in Brazil, and as he fit the continents together in the way he believed they fit together, the mountain ranges seemed to complete each other as if they were just cut off and then split apart eventually. So how did his theory become proven and accepted? Since I already said before how he just never got it accepted in his lifetime because he just had these coincidences of, hey, maybe these were together at some time because fossils are the same and they kind of seem to fit together like a puzzle piece. He just never had enough solid evidence to support this. So as scientific data moved on, they realized that the giant land bridges, which were a theory instead of the continents having moved, that land bridges were just there, that ended up being disqualified because it was discovered that the land bridges were too light to ever have sunk into the seafloor. So they thought that they were just giant land bridges and that they just sunk over time. And as they started analyzing the seafloors, they saw that there's no rock down there that would have been heavy enough to sink down from the top. So those would have just floated and they would never have actually sunk down as the way people thought it was. They also looked at glaciation patterns. So 380 to 250 million years ago, it shows that, as we look at the glaciation patterns now that were in South America, Africa, India, Antarctica, and Australia, we see glacier patterns, but half the places now we don't even see glaciers. So one thought was that as all the countries were joined together, glaciers moved around between them. And when they compiled the countries and the way Pangea seemed to be formed, those glaciers seemed to go out from the South Pole, and it left its traces throughout the countries, and it seemed to complete each other again, those glacial patterns, very similar to how the mountains completed in Africa and Brazil and North America and Scotland. And then as we discovered more about the Earth, as scientific data moved on, they started to look at plate tectonics, and those were discovered that the plates had the Earth has giant plates that were broken up, and they would some of them would carry a country, and that helped prove his theory that countries or continents would be moving around because they would move on these giant plates over the Earth. And then we also started to look at magnetic surveys in the 50s and 60s, and these showed magnetic anomalies and irregular patterns on the seafloor, which was seen to be the result of seafloor spreading. Those were discovered by looking at igneous rocks, and the magnetic patterns had seemed to shift over time. As they looked at it, when they lined up in the Pangea form, the magnetic patterns seemed to be much more simple and make more sense. They lined up together, so when they're apart like this, you can see that the magnets are going this way and this way, and when they line the countries up, they go the same way, so the pole didn't actually shift, or it did. So these made the polar wander curves, and we can see that continents like North America drifted 30 degrees west from Europe, causing the lines there to shift as well. So all those together helped support his theory. So with the plate tectonics, the polar wander curves, and the glacial patterns, as well as just the evidence he had also with the fossils and the rocks all connecting together and the countries just coming together like a jigsaw puzzle, it just seemed to be a very logical solution to how Earth became the way it is today. Seafloor spreading was kind of the last nail in the coffin that helped it establish that this was what happened, that continental drift was the only possible explanation for how Earth is the way it is. Um, so just to go into a little more detail about that, um, Harry H. Hess said that the oceanic crust is constantly being made by undersea volcanoes in the asthenosphere, um, in the major ocean basins. And as the molten rock from the mantle rises to the crust, it then cools. So new lava comes up here, and then as it cools, it makes this new crust here. And as that new crust begins to cool, it pushes the older crust out, which pushes the continents with it. Um, so the plate margins lie on the surface of the ocean. So when the lithospheric plates separate and carry the continents with them, that would cause the continental drift that has been proven to be correct. So the continents are still drifting today as well. They aren't done. They're going to keep moving just at a very slow pace. So basically, as a summary, the timeline of events, it all started with Pangea. It had So it started with Pangea, and that started to break up 250 million years ago into two supercontinents instead of just the one. So that became Laurasia and Gondwana land. Um, and then, yeah, that started in the Triassic period. And then it was going very, very slowly. So this took so long to get to where it is today. It would go at about 2 centimeters a year, and that's about the same as like the length your fingernails grow. The amount they grow is how fast these were moving away from each other. So Laurasia and Gondwana land started to break apart in the Jurassic period, became more of what we see today in the Cretaceous period, and then today are what we see now. So it's been about a 300 million year process and it's still going. So we don't know. I guess scientists can track now and they can see that in the future they're still going to be moving further and further away. So, in conclusion, Wegener's continental drift opened up a world of scientific research and theories. It led to the discovery of plate tectonics and seafloor spreading, and it helped explain many mysteries of the fossils and the rocks and helps us predict what will happen in the future and just help to explain a lot of scientific mysteries we've always wondered about.